Okay, so in this last part, we're going to go ahead and do an example of systematic sampling. And I always find this to be interesting. I mean, usually we would do it by computer software, statistical generator, but I think it's really interesting to see how we even obtain these type of sampling and how mathematically influenced these samplings are. It's just not, oh, I'm going to go out there and select people. It's mathematical, it's math, right? So here we're going to go ahead and approximate the population size. So we may not always know the population size, and sometimes we can. Determine the same sample size. Let's just say sample size. And then compute the quotient n over n, little n, and round to the nearest integer. And you're going to round down to the nearest integer, and where this quotient that you rounded down to the nearest integer is going to be called k. And k is going to be where we're going to randomly select a number between 1 and k, and we're going to call this number p. And in step 5, the sample would consist of the following integers. We start at p, and then we start adding every k. So in this example here, notice that we're going to create a 5-student sample from the class of 31 students. Okay, so let's go ahead and go into step 1. Right? Step 1 is selecting the number of students in the population. And just be careful here because we could see that we have 0 through 30. So if we counted because we have 0, that would be 31 students. Okay, step 2 would mean that we would select a sample size. Our sample size was given to be 5 students. Step 3 says go ahead and do that quotient, right? Big N over little n will round down to the nearest integer, and that integer will be k. So we have 31 divided by 5. So if we went ahead and calculated that, we could go to our calculator and hit 31 divided by 5 and get 6.2. And so here, if we round down, that means we round down to the nearest integer, which would be 6. So in step 4, you'll go ahead and pick p, right? So you're going to pick a random number from 1 to 6. So what is that p, right? So go ahead, I'll give you a minute. Pick your favorite number, right? Okay, let's pick 4. I'm assuming you picked 4 too. And so now we're able now to select the students. And what we're doing here is selecting the number that's assigned to them. So here, whatever we calculate in step 5 will be these numbers here, and we're going to select those students there. So let's go ahead and go to step 5. Okay, and it says, okay, start with P, right? So if we start with P, right? So the first person in the sample would be 4. Number 2 in the sample would be 4 plus k, so 4 plus 6, and that number comes from k. And then the p came from step 4. The third person in our sample would be 4 plus 2 times 6. The fourth person in our sample would be 4 plus 3 times 6. And the fifth person in our sample would be 4 plus 4 times 6. Okay, and then once again, the 4 is the P, and then here we keep K the same, and we just essentially take, I could put a 1 here if I wanted and a plus 0 times 6 here. So you could see the pattern 0, 1, 2, 3, 4. And the 6 remains the same and the 4 remains the same. So it just changes with each person in your sample. And we only want 5, so I only did it 5 times. And that is the formula in here, right? P plus P, which is the 4, P plus K, so P plus 6 right here in number 2. The third person, P plus 2K, P plus 2K, number 3, and all the way to P plus N minus 1. So notice the fifth person in the sample has the 4 there. So these numbers here are always 1 less than the number of subject in your sample. Okay, so really what it is just like counting every fourth person. So the first person would be person number 4, add 6. The 10th person, add 6. 16th person, add 6. 22nd person, add 6. 28th person, right? So you're just adding 6 after you start at the 4th person. So let's see who that is. So let's go here. And we know that the first person is person number 4, the 4th student. Here, number 2 is the 4 plus 6, which is the 10th student on my list. Here is 4 plus 12, which is the 16th student on my list. Now, we could just kind of find the pattern here. Look, 4 plus 6 is 10. 10 plus 6 is 16. Tell me what 6 plus 16 is, right? The 22nd person. And then here would be the 8th person on my list. Okay, so who are these students? Let me go ahead and highlight them in a cool color, blue. 4th student, Quaresmo. 10th student, Khan. 16th student, Okimoto. 22nd student, to be Roth, and the 28th student, which is Tran. So those are our students that we would randomly select in a simple random sample, right? Using systematic sampling for a sample of 5 students out of 30. So you can see the process is quite lengthy, and this is why we like to use statistical software to do this, because it just is so time consuming. And really, what do we really want? We just want to survey these subjects, a simple survey. So actually collecting the sample subjects will always take longer than the actual survey to the subjects. But that's how systematic sampling will go. So it's good to show you the mathematical background behind some of these sampling techniques, because it really has a strong math background. Okay, and so the last thing we need to talk about is variation in data. Because the data can vary, we need to really talk about how that affects our data from our sample. So for example, I have one that with 16-ounce cans of a beverage. And when I selected 6 16 ounces and weighed the liquid in the can, I got these 6 numbers. I got 15.8, 16.1, 15.2, 14.8, 15.8, 15.9. Why are they not all exactly 16? Well, there's a lot behind this, right? First of all, it could be that a machine does it and the machine needs calibration. There's never exactly 16 ounces of liquid in any can. It's always a little off by maybe 10th or 100th, right? They do the best to make it as accurate as possible. And so this is just called variation, right? This is just part of not everything is perfect and exact as we always want to. So this is one example of variation. Another one is sampling variability, the way we take our samples. So the natural variation of samples is called sampling variability. This is unavoidable and expected in random sampling, and in most cases not an issue. So let's just say I take 1,000 people from a population, and the And the samples I take happen to have a slightly higher percentage of Democrats or the latter, right, Republicans or independent, right? And the actual amount of these general population. Some samples might include more older people and some samples might include more younger people, etc. Some might include more male, more female, more more people from one party or the other, right? This is sampling variability. So to minimize those variability, which is very natural in gathering sample and data, is to use those other types of sampling techniques. Like if you wanted to do Democrat and Republicans, stratified might be a way to go. But then you probably want to do stratified within stratified, right? Because then you want to, well, I don't want a certain one age group. I want a whole selection of age. Okay, now you're going to have subgroups of those groups and have age groups. And then within each age group, you probably have males or females, right? And so I guess you would want to make your sampling technique as precise as possible and as random as possible because you'll get the best results that way. Okay, so what happens if you don't? What happens if you just get bad stuff, right? Well, something was really wrong with your sampling, and we need to talk about that because there is such thing as gathering a bad sample. So these are common sources, right? Sampling bias. Let's say you want to see how young people, young adults vote, and then you go to a senior home. Well, a senior home is not going to have young voters living there, so your whole sample is sample bias, right? Voluntary response, right? That is a technique, and sometimes that's what you have to do. But then again, it could just be consisting of people who always just answer those types of surveys, right? Self-interest. Oh, well, I work for a beef company and I just think that beef is great and I'm going to go to the nearest steakhouse and see if they all eat beef, right? And so that would be self-interest. It's within your interest that you get the good results. Response bias would be a sampling bias where the responder gives inaccurate responses. So that means they might lie or just because they have guilt, I don't know, or they just don't want to answer correctly. Perceived to lack anonymity, and that's sampling bias where the responder fears of giving an honest answer. Like some is how many sexual partners have you had, right? How many drugs have you taken? I mean, those are really like personal, judgmental questions that I could see many people not wanting to be accurate in their answer at all. So you really have to think about what question you're asking and how you can make a person or a subject feel as comfortable as possible to answer those questions, even if they're hard questions. Loaded questions. Some researchers love to load the questions in so that you really don't get a true response. It ends up influencing the response. Like guns kill people and guns kill babies. Do you believe in guns? And it's like, well, geez, God, like as long as you are licensed and you're trained, of course, someone should have a gun. And then you're like, but I don't want to kill a baby, so I don't believe in guns, right? So again, the way you load the question, sometimes this is on purpose because it's a self-interest study, and so they want to load you with questions to influence your response. So that's another one of biases. And then the non-response bias is no one cares and no one's going to answer your question, right? So people refuse to participate. Leave me alone, right? And so these are all results from taking bad samples and bad studies. What results taking a bad sample? Bad data. And bad data means bad results, and you have to start all over. So sampling is going to be really important because that's where you're going to get your data from, and that's where you're going to get your descriptive statistics, and that's what you're going to do inferential statistics, and it's all going to go down the drain if you don't have a good technique in gathering your sample to gather data. Okay,